Okay, so problem 1C, every single person messed up. Everybody that I saw just drew a line that looked like that, which is a linear function with a positive slope. Well, we know that a quadratic function is going to give you the derivative that is a linear function. So this is not a quadratic function. This is our two-thirds graph, our x to the two-thirds, the bird's graph. But I want to think about this without actually thinking about the equation of the function. Because again, to sketch the derivative, all you need to do is analyze what you have here. So again, think about these tangent lines here. If I look at the tangent line right there at, say, that point, I see that it is a positive slope. Compare that to this one right here, which is also positive, but it is steeper. Go even closer and closer in. If we get super close in here, notice that the tangent lines are getting steeper and steeper and steeper, and eventually you're going to get one that's going to be pretty much just like that, pretty much just like that, going up towards positive infinity, heading towards a vertical line there. And if you look on the left side there, it's going to be the same exact idea, except these slopes are all negative, but negative getting more negative, steeper, 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 heading up again towards that vertical line. So you need to represent that with your derivative. So again, we had positive slopes here and negative slopes over here, and the derivative was less steep on the outside and steeper on the inside. What function do you know that kind of looks like that? This isn't the same function, but it is going to look a lot like that 1 over x graph. It's not the same, keep in mind. Oh, and that should be positive there, my bad. So I need to draw that like this because we determined those slopes were positive versus this negative one right there like that. And we do have an asymptote running down the middle. So this would be an example of a function that is not differentiable at x equals 0. But now pretend we did take the power rule. We had x to the two-thirds. So if we took the derivative of that, d over dx of that thing, well, we're going to get 2/3 times x to the negative 1/3, which is 2 over 3 times the cube root of x, which apparently looks a lot like 1 over x. Kind of interesting.